This is Physics 1211K, Lab 3, Black Hole. In this lab, we observed the motion of a star orbiting a black hole of unknown mass. The unique trajectory of the star was generated based on an email address. The purpose was to analyze the star's motion to find the net force, and then calculate the mass of the black hole using Newton's second law. After completing the lab, the net force was found to be 7.74 times 10 to the 28th newtons. The mass of the black hole was found to be 8.49 times 10 to the 33rd kilograms. I calculated the initial and final momentum vectors from the given initial and final velocity vectors. Momentum is equal to mass times velocity. The equations on the left are the equations used, and on the right was the GlowScript code that I used. To calculate the change in momentum over time parallel, I first found p hat by dividing the initial momentum vector by the magnitude of the vector. Then, I calculated the magnitude of the final momentum vector minus the magnitude of the initial momentum vector divided by the change in time. I multiplied this value by p hat to find the parallel component of the change in momentum. This value was also equal to the parallel component of the net force. Again, on the left are the written out algebraic equations, and then on the right are what was typed into GlowScript. To find the mass of the black hole, I used the gravitational force formula. This formula states that the gravitational force is equal to big G times m1 times m2 divided by the distance squared. I used algebra to get the mass of the black hole is equal to net force multiplied by distance squared divided by G, big G multiplied by the mass of the star. At the top is the algebraic written out equations, and then at the bottom is what was typed into GlowScript for my code. In the model, the pink arrow represents the parallel component of the net force. The orange arrow represents the perpendicular component of the net force, and the blue arrow is the total net force. The total net force on the star was calculated to be 7.74 times 10 to the 28th newtons, and the mass of the black hole was found to be 8.49 times 10 to the 33rd kilograms. Although the net force and the change in momentum are mathematically equivalent, they represent different things. The net force is what causes the momentum of an object to change. Also, the change in momentum can be calculated from the observed position, mass, and time data. The net force can't be calculated from observable data, so the value of the net force is set equal to the change in momentum since they are mathematically equivalent.